Large samples are nearly always better than small samples. To understand why, you simply need to remember the law of large numbers. This law states that, as our sample size grows, its mean tends towards the average of the whole population. Basically, the more samples we have, the less likely it is that we get fooled by randomness. This law is frequently illustrated with dice rolls. We all naturally understand that each side of a six-sided dice has the same probability of appearing, as long as the dice is fairly weighted. Ultimately, because of this feature of dice, we'd expect the average of a large number of rolls to be 3.5. When you simulate dice rolls, getting exactly 3.5 is actually kind of rare. You tend to see some variation from the mean just due to randomness. But how much variation depends significantly on how big your sample is. After one roll, your average is never 3.5. It's not even a possible result. After 10 rolls, it can commonly be quite a bit off. But as we increase our simulation to 50 rolls, then 100, our measures tend to move closer and closer to the real mean. By 200 rolls, you tend to get a number very close to 3.5 in simulation after simulation after simulation. You can also see this in our earlier simulation of 100 dice rolls. Initially, it looked like our dice was biased. But our simulation progressed very close to the mean when our sample size was increased to 1,000.